welcome you to my lecture today. Of course, the other time we started hypothesis testing, and we only focus on one population. When I say one population, I mean one group, and of course, walk you through how to test hypothesis about the mean and proportion. But today, I'm just going to say this week, we're going to be focusing on two populations. And when I say two populations, of course, I'm going to walk you through how to conduct hypotheses about how do we compare means in two populations and how do we compare proportions. So today, the focus is going to be on comparing proportions from two populations. And if time permits, of course, I can also walk you through comparing means in two populations. Okay, so that is the outline. But like I said, I'm going to start, you know, by testing hypotheses about difference of proportions. Now, let me tell you the way statistics actually work, the way mathematical related subjects actually work is, when you give your own example. When you give your own example, I'm going to give you example on, testing difference of proportions. You can also cite your own example as well. For instance, if I want to compare the proportions, is there any difference between the proportions of, two particular group? Like, for instance, they were vaccinated with, we got different kind of COVID vaccine. I remember Pfizer, I remember Moderna vaccine. Let's say we got two different group of, people. They were actually vaccinated with two different vaccines. The essence of the vaccination is actually to prevent the occurrence of catching COVID. And we now want to see which of the vaccine is superior to preventing that ugly situation. And we decided to look at the difference between the proportion of those who catch COVID using vaccine A and vaccine B. Okay, so that's, you can actually test hypothesis about what difference of that proportion is going to be. Okay, what of in a situation whereby you want to compute the difference of proportion, or probably between what a particular candidate, candidates that have contested for election before, the proportion the candidate got in maybe in 2020, and maybe the candidate also contested for election in 2022, and you now want to compare the difference, because it is not going to be everybody that will vote for a particular candidate that even emerge at the end of the day. So we can use test of proportions in that regard. Now, talking about proportion, we're talking about certain characteristics of interest within a particular group. That's what we mean by proportion. Trying to say, okay, out of this, how many actually possess the characteristics of interest? I can also compare, is there any significant difference between the proportion of those who are living below poverty level in country A? Is there a difference between that, when you compare that to country B? So proportion can be used in that regard. Take a look at this. Everything about, you remember the other time when we're testing, when you conduct hypothesis testing, comparing, I think what we did, we constructed what I call confidence interval. We've done that in this class. where we actually constructed confidence interval about proportion. We can also test hypothesis about proportion, but you know what we got as options. You know, if I'm going to be choosing, it means I'm going to be choosing from two population. Okay. And when I'm choosing from two population, I'm not going to use everybody in the two population. I'm actually going to take a sample. And when I choose sample from the two population, it has to be random. Okay. That's what I mean. And of course, at least 5 successes and 5 failures in both samples. If you take a look at what I mean by this is N1, P1 has to be greater or equal to 5. Okay, N2, P2 also has to be greater or equal to 5. N1, 1 minus P1 has to be greater or equal to 5. N2, 1 minus P2 has to be greater or equal to 5. So this is the number of successes. Okay, so this guy here, the number of successes, and this guy here, the numbers of failures. Okay, now this is the first group, and this for the second group. For the first group, okay, when we are considering a group, okay, we're actually going to have, it is not all of them that will possess the characteristics of interest, which means in a way you are dividing each group into success and failures. So that's exactly what I mean. Now, if we want to test hypothesis, just going to look the same, except the notation. You remember when I was, if you take a look at this now, okay, the non-hypothesis is always going to be equality sign. And of course, you can see the non-hypothesis here is telling me the two proportions are the same. It's more or less like trying to say, the infection or the ability to prevent COVID using two different COVID vaccine is the same. That is what, trying to say the proportion is going to be the same. But when you look at the alternative here, it's trying to say this is less than that, this is greater than that, this is not equal to that. It is the alternative that will actually tell us that there's an effect. Okay, the non-hypothesis remain. There's no effect. Like if you take a look at the non-hypothesis and all, there's no significant difference between the two. Let me tell you this. Some of you maybe, if you take a look at HO, okay, we are not trying to say there is no difference at all. There is. But by HO, we're trying to say the difference is not significant. That's what we mean. Because there's always going to be difference. As I'm saying, there's always going to be difference. But what we're trying to say, the difference is not very much pronounced. Whatever difference that exists here, we believe is due to chance. That's what we call chance variation. Any variation due to chance is not significant. It's not. So, but the alternative is trying to say a significant difference exists. A significant difference exists. Okay? There's a difference here, there's a difference here, there's a difference here in the alternative. Okay? Now, if I now want to test, if I want to, conduct a test, and I want the test statistic now, okay, it's actually going to be this. This guy here, they have a car, is the sample proportion from the group 1, sample proportion from the group 2. This guy here that is 0 is talking about the non-hypothesis, because when the non-hypothesis is true, okay, P1 minus P2 will be 0. The P1 and the P2 here, they are for the population parameters. So these ones are population, okay, proportions. Because when you go to textbook, okay, the way the formula is going to be written in the textbook It's going to look like this. You know, when you go to some textbook, this is what you're going to see. This is what you're going to see when you go to some textbook. But we're trying to say this guy is 0. Why? Because under the null hypothesis, we're trying to say there's no difference between them. Okay. Now, what you use here is what you're going to use here. Now, if you take a look at here, you know, you can see this is 1, right? P2. Okay. Now, if I'm going to show you how you're going to get P cap. The P cap here is more or less like a combined, give me 1 second. I think I have it here too. Let me see if I put it here. Oh, okay. I think I didn't put it here. Actually, I think it's going to be. Does that make sense? This is just going to be. I talk about two group of people were giving vaccine the other time, right? And maybe the event of interest, like from group 1, how many of them? Maybe I want to compare. How is there a significant difference between how the vaccine can prevent the occurrence of COVID? X1 here is going to be the number of in vaccine 1, the number that did not actually catch COVID. S2, the number of people that were vaccinated with vaccine 2 that did not catch COVID. N1 is a sample from group 1, N2 sample from group 2. So this guy here is going to be a combined P cap. Okay, now, but this guy here is X1 over N1, and this guy here is X2 over N2. Does that make sense? Yeah, I think you want to ask a question the other time?
No, that's what.
Oh, okay. Now, if you have that, now, let me tell you this. We're actually going to do this with the assumption that this guy here is a statistic. And statistic varies. What we're trying to say is that this guy has the mean of this guy, and what you see here is the standard deviation. Okay, now take a look at this. At times, I need you to take a look at what you can see here. We are trying to say that statistic follow normal with the mean of this and this, right? And if we want to go by way of a standard normal approach that we've been using, we can also write it this way. And that was the reason why you can see this as this. Now, let's go into how do we take a decision when it comes to testing this. Take a look at this. You know, whenever you are conducting a hypothesis about proportion, whether one population or two populations, it's always going to be Z. Okay? It's always going to be Z. Okay? Now, if you take a look at this now, if the non-hypothesis is less, if I want to get my p-value, it's going to be that. If the alternative is less than, because the non-hypothesis is always going to be equality. If the alternative is less than, this is how you're going to get your p-value. If the alternative is greater than, this is what you're going to use to get your p-value. If it is two-tailed, that is what, of course, I told you the other time. You know, irrespective of the test, okay, what determines the p-value is actually the nature of the alternative. And of course, the conclusion is always, that's how you're going to take your decision. You reject HO whenever p-value is less than a given level of significance. It doesn't matter whatever test you conduct in statistics, whether you conduct a test of mean or a test of proportion, or you are dealing with a one population or two population, it's always going to be that to take a decision. Now, I want to walk you through an example now. Like I said, I need you to be focused. Okay, I need you to be focused. What we're doing now, very, very important. Very, very important. Now, take a look at this question. Survey USA poll 500 Americans and ask if marijuana should be legalized for medicinal purposes. The results of this survey are summarized in the following contingency table. Now, if you take a look at this contingency table, I need you to pay attention to the way the partition they grow, the way the whole population is being partitioned. Take a look at this guy. So, which means they actually want to, they survey those who are less than 50 and those who are more than 50 years. And of course, 202, okay, out of those who are less than 50, 202 said they should legalize that. 108 said no, they shouldn't legalize that. And what is the totality of those who are less than 50 is 310. Now, I will advise that you should know how to interpret a table. How, if you understand what a table is talking about, you're not going to have any issue. Now, the totality in general, okay, of those who said they should legalize is 320 out of 500. And those who said don't legalize is 180. Now, let's take a look at the question. Use this information. Please, I need you to pay attention to the way the question is asked. It's not as if, at times when I think why students normally lose point is because they don't take their time to really digest, like internalize, the question. So I need you to pay attention to this right now. It said use this information to test at the 0.05 level whether younger people are more likely than other people to think marijuana should be legalized for medicinal purposes. I need you to take a look at this. What they are comparing here, okay, they are only comparing the perception of the young and the old. And which means they've taken a side. What is the side? Legalize. Does that make sense? So it is not going to be between legalize and don't legalize again. It is now between the young and old. They now really want to test whether is there equality in their perception about legalize. Now, if that is going to be, so the next thing you're going to do is pay attention to this. What do you see? More likely. Okay? Because you need to be able to, watch out for some words, that will enable you to have a correct specification of the known and the alternative hypothesis. But I'm still going to come to that. Let's first talk about the issue of absorption. Okay? Do we have independent random samples? I think they're talking about survey. And in most of the survey, of course, what they do, take a random sample. That's what they do. Okay. Then another thing is, do we have at least 5 successes? Okay. And 5 failures in both? If I really want to see, of course, we have that, because when you take a look at the number, okay, 202. Don't forget, we are only focusing. I need you to pay attention. I know why I'm saying this. Okay. Now, I need you to look at this. You see the two, right? The 202 and 118, they are actually more than, okay, 5. If you take a look at that, that is the success aspect. Okay, the failure aspect, they don't legalize, say 108 and 72, also greater than. When I say success here means the characteristics of interest. Does that make sense now? Okay, now you're now going to come here again. Population, or you can say grow, young. Less than 50 represent young, and this represent old. What do I want to do now? I need my sample proportions. What is going to be the sample proportion? Is good. You can see 202, because right now we are not interested in don't legalize. Why? According to the question, please read. Maybe in another question, maybe I'm going to change this to not legalize. Does that make sense? So the focus now, the characteristics of interest is legalized, and we only want to test whether the perception of the young and the old is the same or not. Does that make sense? Okay. Now pick up. I told you the other time. Take a look at the formula here. X1 over N1. X is the number of sources. Okay. Now here, that was why you see 202 divided by 310. Don't forget, 310 is the total, the sample that we choose for the younger, okay, and the other one. So take a look at this. We now have this and this. Is there anyone who doesn't understand how we compute the sample proportion right now? These are based on legalize. We're following the question that talk about legalize. Does that make sense? Okay, now after getting that guy, what is the next thing to do? The next thing to do is, how do I know alternative is going to be greater than? Okay, how do I know alternative is going to be greater? Please pay attention. How I know alternative is going to be greater than is because of this. Let me do this. Erase this and take a look at this. Do you see more than? It said, test whether younger people are more likely, more is going to be greater than sign. What if another question? Less, going to be less than. Of course, when you have a greater than, so if they say younger people, then you're actually going to be referring to this guy now. The first population, 1, is for the younger. The second population is for the older. And that is why the specification look like that. Is there anyone who doesn't understand that specification? Because you're going to be the one that will figure out that specification from the question. Now it's a greater than now. Let me tell you this. If you have a wrong specification, your p-value will be wrong, because you need the sign on the alternative to be able to get a correct p-value. And when you have your p-value wrongly computed, you will take a wrong decision. Does that make sense? And that's why you need to be very, very careful. Now we've stated the hypothesis right now. Now the next thing we do is we need, because in the formula, in the formula, this is the formula, right? You see the formula, right? We need a p-cap. And that very p-cap, look at the formula here, right? You see the formula? Okay, I'm going to have the 2 successes divided by the 2 samples, which is what I'm doing here. Any question about getting that? Super easy. Go ahead.
Why do we add instead of subtract?
Why do we add instead of subtract?
Like x1 plus x2 and 1 plus x2.
Oh, you mean, are you talking about this one?
Yeah.
No, you said why do we have? That p-cap is behaving like we're pulling the 2 group, like what is the total number of sources? What is like a combined proportion for the 2 groups? If I'm talking about combined proportions of interest for the 2 groups, of course I'm going to add. Does that make sense? That's a good question. That's a very good one. Now, by the time I plug in, all of that, I'm actually going to have this guy. Okay, my Z actually give me 0.69. If my Z give me 0.69, I want to get my p-value now. Now, getting my p-value, I have to go back to the sign in the alternative. What sign do I have in the alternative? Is greater than sign, then I'm going to say greater than. Okay, the value that I got in the Z. Now I want to check this from a normal table in the final. Of course, you don't need to worry about what you're going to bring. I'm going to, I'm going to attach, the tables, statistical tables you're going to use for the exam to the exam booklet. Does that make sense? Okay, you don't need to worry about, statistical table. They will be provided in the exam. Now, if I go to the normal table now and I check for this value, I'm going to subtract whatever I get from 1 because it's talking about greater than for me to have this guy. Now I got a p-value now of 0.2451. Now when a p-value, now what was the level of significance given? We got to go back now, check what was the level of significance given. Here you are given a 0.05. You see that? 0.05. Now compare the p-value now to a 0.05. You're actually going to see the p-value you got, 0.2451 is greater than the level of significance. And of course, I told you the other time, take a look at the decision here. Okay, when a p-value is less than alpha, you reject. But when the p-value is greater than alpha, you're actually going to fail to reject. So what are we going to do here? We're going to fail to reject because the p-value that we obtain is greater than alpha. And that was why, take a look at, we don't say we accept. If you say we accept, your point will be deducted, your grade, and I don't want it to lose grade, okay? We don't say we accept. We fail to reject because you know what we normally want to test. We want to test if there is evidence against the non-hypothesis. That is always what we want to test. The non-hypothesis is more, I told you the other time, like we are testing, is there any agreement between observations and reality? Okay, is there any agreement between observation and reality? It's either we reject when we have seen sufficient evidence, or we fail to reject, okay, when we have not seen sufficient evidence. Let me tell you this. If this guy go to court and the court, they charge him and accuse it, the court is not saying he's innocent. You know what the court is trying to say? The court is trying to tell the world we do not have sufficient evidence to nail this guy. That's what it means. Does that make sense? Because a court can say this guy is free and this guy really committed the offense. A court can put this guy in jail and this guy naturally is innocent. It's possible. And that is the reason why the court will only take decision based on the evidence before the court. Does that make sense? And that doesn't mean court doesn't commit error. Of course, court commit error. Okay? If you want to know whether court commit error, when somebody don't believe that they don't satisfy with a particular judgment in a particular court, they could appeal. And we see situation where they appeal and the upper court, declare the initial judgment by the lower court null and void. It's possible. Now, here now we're going to say, okay, we fail to reject H naught. See, look at the way I put it. Look at the way I put it here. I try to tell the world, I did not just say we fail to reject, but I have to say because of this. I have to tell the world the reason why I come to that conclusion. Then I'm also going to allow something to reflect in my outcome. Take a look at it. We fail to reject H naught at the 0.05 level because there's possibility if somebody specify a new level of significance, okay, that is not okay. For instance, let's say I say use 30% level of significance, I know that 30% is huge. Let's go back. What do you think will happen? If you compare this with 0.3, 0.3 is 30%. What will happen? You will reject. And that is the reason why, if you take a decision, you need to be able to tell the world, okay, at what level, okay, I'm showing that. Now, take a look at this. If you want to get full points in exam, I need you to pay attention now. There is a difference between a decision and a conclusion. I'm going to tell you now. Let's say court said, based on the sufficient evidence before me, okay, we found the accused guilty. Has the court taken a decision? Have they concluded? No. They've not sentenced the guy. They just find out, because before the court is going to do sentencing, I know they consider some factors. Does that make sense? Now, now, we fail to reject, but we have not concluded. When we fail to reject, then what is going to be the conclusion? We do not have enough evidence to conclude at the 0.05 level that you now refer to the question. You now refer to, the subject matter, what you're doing. If you take a look at the research question in the question before, is whether younger people are more likely, okay, than older people to think marijuana should be legalized for medicinal purposes. You are coming back there. Okay, whenever you want to take a decision, whenever you want to conclude, you need to refer back to the reason why you are doing what you are doing in the first place. Now, that was why we took a look at that and said, okay, since we fail to reject the null hypothesis, okay, we're going to say, we conclude, we said we do not have enough evidence to conclude at the 0.05 level that youngsters are more likely than old stars to support the legislation of marijuana. So what are we trying to tell the world? We are telling the world that this guy here is not likely. We are more or less trying to say the perception is the same between the young and the old when it comes to legalizing marijuana for medicinal purposes. Is there any question? You see the way this is conducted now. For those of, for the practical assignment, let's say somebody want to do something like this. If we follow it through like this, for the hypothesis testing side, oh my God, you're going to have an excellent result. This is the way it should be done. Okay, because I have a lot of time. I'm actually gonna go into the material for Wednesday. Okay, the material for Wednesday. Okay, like I said, all of this are being recorded. Okay, you can check my YouTube. Of course, you're gonna see. Now, let me welcome you to another topic. Today is not December 6th, okay? Today is December 4th. But we finished that guy on time, so, and we get enough time. So, of course, we're finishing our lecture this week, and next week is just going to be revision. You know that, right? Okay. Now, I advise that you attend. Now, I want to welcome you to hypothesis testing of difference of means. Okay, at times, between two populations, you may want to compare averages. Okay, want to compare the standard of living in two countries. Okay, you want to compare, means. Okay, I welcome you to that. But you know what? We have, when you are comparing two groups, okay, two groups, they could be independent, they could be dependent. You remember when I was walking you through constructing confidence interval, when you have a dependent group, we use a paired, right? We're also going to do that in this. Okay, now What we just want to do is to compare, like I said, parameters in two population. Now, take a look at this. Let's have this in preview. Test the claim that when college students are weighed at the beginning and at the end of their freshman year, the difference show a mean weight gain of 15 pounds. Did anybody try it when you came into the university? Did you do it to see whether at the beginning, because they believe you're going to go through some stress, right? So, this could be like, this is, we can test this claim. It's an hypothetical statement. It could be true or not. Does that make sense? Okay. Now, another one is test the claim that the proportion, of course, we just talk about proportion now, of children who contract polio is less for children giving the Salk vaccine than for children giving a placebo. A placebo is nothing. In clinical trial, if they really want to, one of the stages in evaluating new drug is to for of us compare new drug with nothing. Placebo is nothing. And they give you a placebo and you say, oh, I'm okay. Then that person was not sick in the first place. Maybe has a kind of psychological issue. Then to test the claim that subject treated with lipido have a mean cholesterol level that is lower than the mean cholesterol level for subject giving a placebo. So these are examples of comparing means and proportions in two groups. Like I said, I want to focus on when it comes to comparing means in two groups, okay, we need to be able to see, are we talking about dependent or independent? Okay, dependent is just they are using the same individuals, except that they are collecting data from them in more than one location. But for independent, of course, they're using different people. Okay, now this should be very paramount. Whenever you want to compare means in two independent groups, okay, number one thing you should think about is, do they give us population variances? You remember when we're focusing on testing hypothesis about me for one population, we also talk about that, right? Do we have a population variance or not? Now, in the case of two population, we're also going to have assumptions. Do you have population variances given or not? If you take a look at this, I said, independent samples with sigma 1, sigma 2 is population standard deviation unknown and not assumed to be equal. Let me tell you this. Examiner is going to tell you, at times when the population standard deviation are not given, okay, we can assume, despite the fact that they are not given, we can assume they are not the same. And at times we can say they are the same. They are not given, but they are the same. Because when they are not given and we assume they are the same, we're actually going to use the knowledge of pool variance. You remember I walked you through that when we're constructing confidence interval about difference of means as well. Okay, now I'm going to call Mito notation now. Take a look at all this. Mu1, the population mean for group 1. Sigma 1, the population standard deviation for group 1. Of course, we're going to take a sample size from group 1. And we're going to, from the sample size, we're going to find mean, sample mean for group 1. Now, I need you to focus on these notations. Okay, I need you to focus on this notation. Take a look at this. Sample mean for group 1. Population mean for group 1. They are not the same. This is population standard deviation for group 1. This is sample standard deviation for group 1. We're also going to have set for group 2 as well. Any question about all these notations? We're going to have that set for group 2 as well. Don't forget, these two groups are independent. The two groups are independent. Now, what are we going to have as requirement? Okay, requirement, the population standard deviation are unknown, okay, and no assumption is made about their equality. Okay, 2, the two samples have to be independent. The sample you're going to choose from them have to be independent, and both samples have to be simple random. Okay, it has to be random. If I'm comparing standard of living in the United States and Canada. If I choose people randomly from the United States, I also need to choose people randomly from Canada. That's what it means. Okay. Now, another condition. Another condition. Either or both of these conditions are satisfied, the two sample size for large, it has to be greater than at least 30. You remember we were dealing with one population, but this time around, they have to be at or both samples come from populations having normal. You remember the other time, it's either where the population is normal, or if the population is not normal, provided the sample size is at least 30, we can still use a large sample procedure. Let's talk about what the formula is going to be. Take a look at this guy. This is going to be the formula now. When you take a look at what I have here, right? When you take a look at what I have here, like a difference of the sample means difference of the population mean. The difference of the population mean is 0. You remember the other time when we're dealing with the proportion, say difference of population proportion is 0. But that is what is assumed under the null hypothesis equality. Okay. Now, which is what I said here. Now, let's take a look at this question. Please, I need you to pay attention. A headline in USA Today proclaimed that men, women are equal talkers. Okay. Now, that headline referred to a study of numbers of words that samples of men and women spoke in a day. I can't even, I lost track of my own because I talk a lot because I teach. Okay, given below are the results from the study. Use a 0.05 significance level to test the claim that men and women speak the same mean numbers of words in a day. Can somebody tell me, where is the claim here? Is the claim in the alternative or in the null hypothesis? Can somebody tell me? There's a claim where?
No.
In the null. Because at times a claim could be in the null, a claim could be in the alternative. Take a look at it. It said, test the claim that men and women speak the same mean number of words in a day. Now, does there appear to be a difference? Oh, does there appear to be a difference? Then the alternative will be not equal. Because does there appear to be a difference? It didn't tell us whether something less or something greater. Now, you were given all of this for men. We have information. Take a look at this. 186 men were chosen. It is not only 186 men that we have in that particular place. They choose 186. From the 186, they ask each of them, and they have values of the numbers of words spoken, and they find the average. The average is that. The standard deviation is this. This standard deviation is sample standard deviation. It's coming from the sample. We do the same thing for women. But let me tell you this. If you don't want to conduct a statistical test, and you just look at the numbers, let's just look at the numbers. If you just look at the numbers without conducting statistical test, if you look at I know some of you will only want to compare this. Without statistical test, you're going to say women actually have more, right? Without conducting statistical test. But the difference that you see here, even though there's a difference between this and this, but that difference may not be significant. And that is the reason why we need a statistical test to be able to figure out if there's a statistical significant difference between two entities. Now, what am I going to do? I got all of that now. Okay, then I'm just going to come here. Okay, I've put all of that here now. Look at that. Okay, now I got this result now. Okay, and what I'm going to do, because you have been told here, we do not have the population side division were not given, right? And since they were not given, we can make use of T okay, even though some statistician is still going to argue this out, like, okay, we can also make use of Z. Why? Because of the fact that the sample size is extremely large. And let me tell you this, statistically speaking, when sample size increases, T distribution behave like a Z. That's another thing we find out. Okay, so if you now you will notice that we actually have two sample size and we need a degree of freedom. Okay, you choose the smallest one, the smaller one. Which one is the smaller one? This one, right? Subtract 1 from this. That will be 185. Like I said, if I want to get a degree of freedom now, I'm going to subtract this from 1, and I'm going to choose the smaller one. What is the smaller one? That will be the one for 185. And that is what, if I want to go to T table, okay, that's what I'm going to check. But in a situation where that value may not be in the T table, what are you going to choose? Choose the closest value. Does that make sense? Because it's not all the time you're going to see the degree of that degree of freedom value in the T table. Now, when you choose the closest value, what am I trying to say here? Okay, what I'm trying to say here, the test statistic value that I got was this, okay? And if you take a look at this side and this side, you know, when I'm talking about two-tail, alternative is two-tail, the rejection region is going to be here and here. Does that make sense? Acceptance region is this region. Acceptance region is where we normally fail to what? To reject the non-hypothesis. Is this region for two-tail tails. This is two-tail tails. How do I know it's a two-tail tails? Okay, because, you know, going by the statements. Now, when I check for that values now, of course, that's what I'm going to get. Then in the end, in comparing, you know, I can find the p-value, okay? If you want to find, you can find the p-value based on this. If you want to find the p-value based on this, don't forget, find the absolute value, right? When you find the absolute value and you get a p-value for that, whatever you subtract, whatever you check from the table from 1 multiplied by 2 for you to be able to take your decision. Okay, another one. Now, in the end, we realize there's no sufficient evidence to warrant rejection of the claim that the men and women speak the same number of words in a day, and there does not appear to be a significant difference between the two means. So I think I'm going to continue from, oh, wait a minute. I still have like 3 minutes. Let's quickly do the other one. Independent sample with unknown. Now, take a look at this. Population variances, population standard deviation are unknown, but they are assumed to be the same. If they are assumed to be the same, this is where you're going to use the pool variance. This is the data. Here the question, here they say, is there sufficient evidence to indicate a difference in the true mean assembly time for that? And we're giving all of this. Now, what is the difference? Here, they give you something like this. You can calculate your sample variance from it by dividing this by sample size minus 1. This is by 8. That will give you the sample variance here. By dividing this one, that will give you the sample variance here. So let's quickly go because we have the, so in this one, you remember what we did the other time? We used to compute the what? Pool variance. Why? Because they say the two population standard deviation are not given and they are assumed to be equal. We're going to pool. So take a look at that. In the pooling, okay, in the pooling, you remember the formula that we used the other time, N1 minus 1. I'm going to quickly write that. You remember that? That's why you're going to, it's super easy. Then after I get a lot of that, you plug that in. You got this guy here. Now, we're actually going to take a decision. Oh my God. We're done with what I prepared for Wednesday. We're done. Any question? So, which means because I want us to finish our remaining work on time so that you're going to have enough time to prepare for the final so that the least in this class for the final will score 99%. I know that one for sure. Is there any question before I go today? Okay, make sure you all stay safe and have a lovely day. Bye for now, everyone.
I'm so glad I didn't find out live. Yeah, you know the WBS.